This question deals with second messenger pathway. Now let's get right into it. The question says that interaction of certain growth factors leads to the following sequence of events. Now what's the sequence of events? First, there is binding of growth factor ligand. After binding, this leads to autophosphorylation of the tyrosine residue. Then there is interaction with SOS protein, which leads to activation of X protein. That leads to activation of RAS protein kinase, activation of MAP kinase, eventually leading to gene transcription. Now the question says, protein X becomes activated and binds to which of the following? Is it ATP, CAMP, IP3, GTP, or calcium? Okay, now let's go back in the pathway. So there is activation of SOS, which leads to activation of X protein, and we don't know what X is, so we have to find out from this list. This leads to activation of RAS protein. So it's from between tyrosine residues, autophosphorylation of tyrosine residues to interaction of SOS to RAS. Between that, what happens, what product is activated or what protein is activated, that's a question that they're asking us. Okay, so if you're not too familiar with second messengers, first of all, the first thing we have to do is find out what is the substrate that they're talking about. And in this question, how can we know the substrate? We read the vignette one more time. So we go at the very top and we read, interaction of certain growth factors leads to the following sequence of events. So even if you're not completely have a good grasp of what sequence that they're talking about, at least you know that they're talking about growth factors. So let's talk about growth factors for a little bit. So we know that certain growth factors and insulin is G protein coupled receptors, and they follow the MAP kinase pathway. So what are those growth factors? It can be platelet derived growth factor, it can be fibroblast growth factor, it can be insulin growth factor 1. And also insulin. So these are the things that is going to follow the G protein coupled receptor in the MAP kinase pathway. Now, here's a question for you. What if I say that the product is prolactin? What second messenger pathway is prolactin going to follow? Okay, so if you remember, it's from page 321 from first aid. You'll see that they have a list of all the second messengers there. So you'll see it there as well. They use the mnemonic PIG, okay? P for prolactin, and I for interleukins, and G for growth hormones, okay? So don't confuse between growth hormones and growth factors. This is growth factors. This is going to follow the G protein coupled MAP kinase pathway. Growth hormone is a little bit different. They're also going to be G protein coupled, obviously. They are going to follow the JAK-STAT pathway. Okay, they're going to also follow the JAK-STAT pathway. Here I want to, add something a little bit extra. I usually use PIG-E, and for E, I put EPO or erythropoietin. That also follows the JAK-STAT pathway. That's one interesting difference. So both are going to be G protein coupled, but growth factors is going to follow the MAP kinase pathway, and the PIG-E is going to follow the JAK-STAT pathway. Another key difference is that the MAP kinase pathway is intrinsic. Okay, so first the receptor is going to bind to the ligand, and then everything else is going to trickle down the cell. That's intrinsic. But with the JAK-STAT pathway, the ligand is going to bind to the receptor, and it's going to become autophosphorylated, and it's going to go directly to the nucleus for transcription. So, do I really, have I made this clear? So the MAP kinase is going to be through tyrosine kinase pathway as well. This is also tyrosine kinase pathway, but one key difference is that this is intrinsic and this is receptor mediated. Okay, This is receptor mediated. So it has no intrinsic action really. If it binds to the receptor, it's going to go to the nucleus for transcription. But the intrinsic pathway, it's going to, it's going to phosphorylate, it's going to go through a series of reactions, and then eventually it's going to go to the nucleus, but all these things are happening intrinsically. So that's one key difference. So I'm deviating away from the topic here a little bit because just to keep everything in the picture. Now what if I say what second messenger is going to deal with our heart rate? Okay. Now we know in our heart we have the beta 1 receptors, and we know beta 1, beta 2, delta 1, H2 and V2. These are the receptors which is going to go through the GS pathway, which is going to stimulate protein kinase A and henceforth. Now what if I say what receptors are, what second messenger is triggered by okay, let's say alpha 1. Okay, so we know that the mnemonic have 1 MNM, okay, H1, alpha 1, V1, M1 and M3 have 1 MNM. This is the pathway that deals with GQ pathway, right? So that's going to increase our phospholipase C, which is also going to increase IP3 DAG and henceforth. Okay, so that's the second messenger. That's the kind of G protein coupled second messenger it's going to follow. Now let's extend this thought a little bit more. What if I say what second messenger are we going to see it with FSH or LH? What are you going to say then? Now second messengers coming from mostly from the pituitary is going to follow the CAMP pathway. Okay, so anything that's going to stimulate the adenylate cyclase pathway. The mnemonic is really flat champ. Okay, this is the mnemonic, and F